Find each probability. A, the probability of flipping a quarter and getting ahead, and flipping the quarter again and getting ahead. We decided in the last exercise that these two events were independent. And what we're saying in the notes is that if you have independent events, then probability can be found by taking the probability of A and B and applying the formula. Probability of A times probability of B. And this is for A, B, independent. So this applies here. So what is, then, the probability of getting our first head? And the answer is, well, there's one head out of two outcomes. It's 1 out of 2. Times the probability of our second head. And again, it doesn't change regardless of what happened the first time because it's independent, so it's also 1 out of 2. Final answer, 1 out of 2 times 1 out of 2. The probability of getting a head and then a head is 1 in 4. B. The probability of rolling a die and getting a 4, and then rolling that same die and getting a 3. So remember that these were independent events also, so we're looking at the probability of 4 times the probability of 3. So let's break down each of these. So how many sides on our cube have a 4 on them? Remember, there's 6 sides. One has a 1, one has a 2, one has a 3, and one has a 4, one has a 5, one has a 6. Well, there's only one side that has a 4. Out of how many total sides? They're all equally likely, so just count 6. The probability of getting a 4 when you roll this die is 1 out of 6. You want to get a 4 and then a 3, that's easy. Just multiply because they're independent. When you roll a die, you start all over. So what is the probability of rolling a 3? Well, it looks like we rolled a 3 right here. There's only one side that has a 3 out of the 6. So it is, again, also 1 out of 6. Our rule for probability says that you just multiply, and the probability is then 1 out of 6 times 6, 36. C. Here, C and D were dependent events. And so the probability there for dependent events is probability of A and B is equal to the probability of A, again, it's multiplication, times the probability of, you can't just say B though. In the notes I put B with a straight line A, and what that means is it's the probability of B, but given that A already happened. All right, so let's see what this means to us in problem C. So problem C. So we're selecting a card from a deck and getting a jack. So first things first. So the probability of that happening. How many jacks are there? Well, there's 4 jacks. And when we start, how many cards are there? 52. They're all equally likely, so the probability is 4 out of 52. And again, we multiply. But now, probability of B given A. Let's see how this works out. What's the probability of getting a jack and then selecting a card from the deck and getting a jack again? Well, I did not replace that first jack, so how many jacks are left? Well, there's only, if we selected one the first time, there was 4 to select from out of 52. The next time around, there's only 3 left because I didn't replace it. And out of how many total cards? 51. And so our answer is 12 out of 52 times 51. And this is why you should always have your calculator handy. So 52, 5 times 2 is 10. Here's the 1, 26. And it looks like we get 12 out of 2652. Okay, and now problem should be D. E. Probability of selecting a card from a deck and getting a queen, and selecting another card and getting a king. So when we select that first card and we look at the probability of getting a queen, there are 4 queens out of 52, just like for the jack. But now when we go to make our second selection, again we're not replacing, again we have dependent events, and again we're using this formula, but we're not looking for a second queen in this problem. We're looking for the probability of getting a king now. So if you picked a queen the first time, there were 4 out of 52. Now, there still are 4 kings left, but it's out of how many cards? And the answer is 51. So the probability of selecting a queen and then selecting a king is 16 out of 52 times 51, which again is 26